Hi guys, so this is my first video and my new channel. So here I'm going to teach all chemistry. It's all about chemistry, and if you want me to explain any topic, please do mention in the comment section and please do subscribe my channel. So basically first I want to do medicinal chemistry, so that's quite interesting. And the first drug which I'm going to teach is cardiovascular drugs. So cardiovascular means all heart related problems related to a cardiovascular system. So cardiovascular system is a heart. So the diseases, for these diseases, cardiovascular diseases, these cardiovascular drugs are used. So cardiovascular diseases, there are many, to name them few. Angina pectoris, this is a disease in which the heart doesn't get sufficient blood, so you get a chest pain. Then arrhythmia, in which your heartbeat is abnormal, like is it too low or it is too fast. So hyper and hypo, we know that hypo and hypotensive, that is low BP, high BP, that is pressure on the blood vessels. Stroke is not a heart attack, it's a brain attack, not even brain attack, but when a brain doesn't get enough blood, or there's some clot in the blood vessel which carries the blood to the brain, then we get stroke. Heart attack and heart failures are not at all same. So in heart attack, your heart muscles doesn't get enough sufficient blood, so there it's a heart attack. Heart failure doesn't mean that your heart dies or it fails, okay? It just means it's simply that the pumping isn't well, so there's no proper blood supply. So to cure these diseases, there are varieties of drugs. First one, we're going to start with amyl nitrite. So this is a nitrite. Nitrite is NO2 minus. So how do we synthesize amyl nitrite? Okay, the first one which we are going to study is amyl nitrite. It's a nitrite. Nitrite is NO2 minus. And nitrate, that is TRATE, is NO3 minus. So nitrite will have a structure somewhat like this. So there is a negative charge, one negative charge. To satisfy this nitrogen valencies, so this bond moves up, and so nitrogen has 3 bonds and a lone pair, and this oxygen gets a negative charge, so NO2 minus. This is nitrite. So the starting material are, we use a amyl alcohol, or you can give a IUPAC nomenclature as the functional group gets 1, 2, 3, 4. So on the third position there's a methyl group, so you can call as 3-methyl. It's a 4 carbon chain, so it's a butane. So 3-methyl butanol, because of OH, butanol. When it's treated with sodium nitrite, we need a nitrite group, and H2SO4. This is acid catalyzed. It's an acid catalyst. So we use the acid catalyst and we get an amyl nitrite. This is like, it's a simple substitution reaction in which the OH is protonated. It becomes OH2 plus oxonium ion. So this becomes OH2 plus, is a good leaving group. So when this exists as Na plus and NO2 minus, so it simply attacks this. When first this is protonated, it becomes okay. Then when this attacks this, it leaves, so we get O, that is, first it is protonated, it becomes OH2 plus, and this is a good living group, living group. So, and then I'm just okay, this is carbon, think this whole chain, and then this is in a form of, it's a nucleophilic nucleophilic substitution. So this negative charge of carbon will attack this, a negative charge of the oxygen attacks this carbon, and hence this leaves out, and we get the amyl nitrite. This amyl nitrite is an anti-anginal drug. As we discussed anginal pectoracis, it is used to treat this anginal pectoracis. So it's an anti-anginal drug used for ischemic heart attack, heart diseases. It is quite volatile and it is inhaled to obtain a rapid effect. And this is chemically related to nitroglycine, and it has been used for treatment of angina pectoracis, as I said, and even it is used for cyanide poisoning also, used for whooping, coughing, and asthma. So the next drug is sorbitrate. Even this is a anti-anginal drug, and a form of this amyl nitrate. All are it is taken through sublingual route. That is, you have to just put under your tongue, and this gets dissolved and goes into your bloodstream and then to your heart or heart vessels and gives a rapid effect. This is also same type. Here the static material we used is D-glucose. I hope you all know how to give nomenclature and give DL notations for this. So this is a glucose structure, and as we see, the OH is the second carbon, the last second carbon. OH is on the right hand side. So this is a D-glucose. D-glucose on reduction with using platinum catalyst on reduction. This aldehyde group is a reducing sugar, so obviously it gets reduced. So this aldehyde group gets reduced to a alcohol group. That is, reduction is simply addition of hydrogens. So two hydrogens get added and you get an alcohol. This on treatment with 40% H2SO4 or 60% HCl or 85% PTSA. PTSA is nothing but para-toluene sulfonic acid, undergoes a cyclization. It undergoes a cyclization, and then as it is rate, we know nitrate should be present. So this on treatment with nitrating mixture, that is concentrated HNO3 and H2SO4, we get sorbitrate, where OH groups are simply substituted by nitrate group. The mode of action for this is, it involves a free radical NO radical which interacts with the guanylate cyclase enzyme. This is an enzyme. The NO radical form interacts with this enzyme, and even a nitrothiol intermediate is formed by the reaction of a nitrite with butyrathiazole. This formed is activates a systolic movement, and this is also this helps in protein kinase, mediates the dephosphorylation of myosin. As we know, myosin is a smooth muscle. It's a smooth muscle, so this helps in relaxation of smooth muscles. That is myosin. It helps in relaxation of smooth muscles. This myosin now cannot play a so here this enzyme dephosphates this myosin, and hence this myosin now cannot play a normal role in contraction process of the smooth muscles, and thus this results in relaxation. So this is a synthesis of sorbitol. So the next drug is verapamil. This is also anti-anginal and anti-arrhythmic drug. So it is for both, and it is used in a levo form, levodopa, and these control and manage. It manages supraventricular arrhythmia. So let's see the synthesis. So we use this starting material in which at third and fourth position there is a dimethoxy group present. At this position there is an isopropyl group attached to a CH, and it is attached to a nitrile group, C triple bond N. This starting material on treatment with a strong base, it's an alkyl base, strong base. We know this is a nucleophilic center, so this will abstract a hydrogen from this carbon, as this carbon is acidic as it is attached to a nitrile group. So we get a carb anion, and then we treat with this structure to get this drug. So here at the point of attachment we take any halide, because we know halides are good living groups than fluorine. Fluorine is a very bad living group, poor living group, but other halides are a good living group. So this will attack this carbon and the halide is displaced, and hence we get this structure, verapamil. So this verapamil, it is a calcium ion entry blocker. It acts directly by interfering the conductance of a calcium ion. We need calcium ion for conductance, for cystone, diastole, for cystone. Okay, but this blocks the calcium ion. So and this drug is a prodrug. Prodrug means this is a inactive form, but when it is in vivo, it becomes towards active form, and its active form is norverapamil. So the next drug is methyl dopa. This is a antihypertensive drug. It is used for antihypertensive. It's an antihypertensive drug. So in this, it's a vasomotor. It acts directly on the brain and the central nervous system, and it is metabolized in the central nervous system to methyl norepinephrine, to its active form. This is also a prodrug which in the central nervous system it is metabolized to its methyl norepinephrine, which produces antihypertensive effect. So the starting materials are, here also there's two methoxy group present, so always functional groups get 1, 2, 3, 4. So this is like what do you call as at one position 1, 2, 3. So this is a propane chain with a keto group, so propanone, and this propanone we go to according to alphabetic order. So 1, 3, 4 dimethoxy, because there are two methoxy groups at third and fourth position. Dimethoxy phenyl, this is a phenyl group, phenyl, and then propanone, it's a non keto group is present, keto. So when this is treated with potassium cyanide, so this is a addition of cyanide group here, when it's like a nucleophilic substitution reaction with cyanide, as this carbon is deficient and even this carbon is deficient. These are deficient centers, so this will attack here. It's in the form of this, so this will attack this deficient center, this will move, and this negative charge on the O will pick up a proton from the base and becomes OH, and this is a nitrile group here. We need amine group, so we introduce amine group by NH4Cl, ammonium chloride. So treat with ammonium chloride, you get NH2, and then again we have to hydrolyze this cyanide, so we use concentrated H2SO4. We did, and this is hydrolyzed. It's a acid hydrolyzed, so it's hydrolyzed to acid first, it's hydrolyzed to amide and then to an acid, and hence we get methyl dopa. So there's even one more drug, quinidine. It's an alkaloid, and it is an anti-arrhythmic drug. So the synthesis is quite long, so I don't want to take it, but if you want the synthesis of this, please do comment it. And thank you for watching this video. Please do subscribe my channel for more interesting videos.